How stars are born. Nebulae. When we look up at the night sky, the stars may appear as tiny, steady points of light that have always existed. In reality, every star has a beginning, and its story starts in a vast and mysterious region of space known as a nebula. A nebula is a massive cloud of gas and dust, often stretching across many light years. These clouds are mostly made of hydrogen, the simplest and most abundant element in the universe, along with helium and traces of heavier elements. Nebulae are often called stellar nurseries because they are the places where new stars are born. One of the most well-known examples is the Orion Nebula, where scientists have observed many young stars forming and shining. Although nebulae may look calm and beautiful in telescope images, they are actually very active environments. The process of star formation begins when a part of the nebula becomes unstable and starts to collapse under its own gravity. This collapse can be triggered by various events, such as the shockwave from a nearby exploding star, or by the natural movement and collision of gas clouds within the nebula. As gravity pulls the gas and dust inward, the material begins to gather into a dense region. This early stage is known as a protostar, which is essentially a young star in the process of forming. As the protostar continues to grow, it gathers more and more material from the surrounding nebula. This process, called accretion, causes the protostar to increase in mass and temperature. The material falling toward the center does not move in a straight line but instead forms a spinning disk around the protostar. This rotating disk is important because it not only feeds the growing star but can also become the birthplace of planets, moons, and other objects. Over time, the center of the protostar becomes extremely hot and dense due to the constant pressure from the collapsing material. Eventually, the temperature at the core reaches a critical point where nuclear fusion begins. This is the moment when hydrogen atoms start to combine to form helium, releasing a tremendous amount of energy in the process. This energy produces light and heat, and the protostar officially becomes a true star. The outward pressure from this energy balances the inward pull of gravity, creating a stable state that allows the star to shine for millions or even billions of years. This stage is known as the main sequence, and it is the longest phase in a star's life. The size and brightness of a star depend on how much material it collects during its formation. Large stars form from bigger and denser regions of the nebula and burn their fuel quickly, shining very brightly but living shorter lives. Smaller stars, on the other hand, form from less material and burn their fuel slowly, allowing them to exist for much longer periods. Our own Sun is a medium-sized star that formed from a nebula about 4.6 billion years ago, and it will continue to shine for billions of years to come. Nebulae themselves come in different types, each with unique characteristics. Emission nebulae glow brightly because they are energized by nearby young stars that excite the gas within them. Reflection nebulae do not produce their own light but instead reflect the light of nearby stars, creating a soft, glowing appearance. Dark nebulae are dense clouds of dust that block light, making them appear as dark patches against brighter backgrounds. Interestingly, these dark nebulae are often the very places where new stars are forming, hidden from view until they become bright enough to be seen. As new stars are born, they begin to influence their surroundings in powerful ways. The radiation and stellar winds from young stars can push away the remaining gas and dust, clearing out parts of the nebula. This process can either stop further star formation in that region or trigger it in nearby areas by compressing the gas. In this way, star formation can spread through a nebula like a chain reaction, leading to the creation of entire clusters of stars. These clusters can remain together for millions of years before gradually drifting apart. Another fascinating aspect of star formation is the creation of planetary systems. the rotating disk of gas and dust around a young star, known as a protoplanetary disk, contains the raw materials for planets. Over time, particles within the disk collide and stick together, forming larger bodies that eventually become planets, moons, asteroids, and comets. This means that the same process that creates stars also leads to the formation of solar systems. The planets in our own solar system were formed from such a disk around the young sun billions of years ago. The study of nebulae and star formation helps scientists understand the origins of the universe and everything within it. The elements that make up planets, oceans, and living organisms were once created inside stars. When stars reach the end of their lives, they release these elements back into space, enriching nebulae with the materials needed for the next generation of stars. This continuous cycle of star birth and death is essential for the evolution of galaxies and the creation of complex structures in the universe. Modern technology has allowed scientists to observe nebulae in incredible detail. Space telescopes like the Hubble Space Telescope and the James Webb Space Telescope have captured breathtaking images of these regions, revealing intricate patterns of gas, dust, and newly forming stars. These observations have deepened our understanding of how stars are born and how the conditions within nebulae influence their formation. The James Webb Space Telescope, in particular, can see through dense clouds of dust using infrared light, allowing scientists to observe stars in their earliest stages of development. In simple terms, nebulae are the birthplaces of stars, where clouds of gas and dust come together under the force of gravity to create new sources of light and energy. The journey from a diffuse cloud to a shining star is long and complex, involving powerful forces and delicate balances. Every star we see in the night sky has gone through this process, making nebulae one of the most important features of the universe. The next time you look up at the stars, remember that they were once part of a vast cloud drifting through space. Over millions of years, gravity brought them together, ignited their cores, and turned them into the brilliant objects we see today. This understanding connects us to the universe in a profound way, reminding us that even our own sun was born from a nebula. The study of star formation not only explains how stars come into existence but also inspires curiosity and wonder about the vast and ever-changing cosmos. If you enjoyed learning about how stars are born and the role of nebulae in this incredible process, do not forget to like the video, share it with your friends, and subscribe to the channel for more engaging and easy-to-understand content about space, science, and the wonders of the universe.